So welcome back folks, this is Shakil Gavande from Ace Knowledge, and in this video we are going to perform page replacement with the help of LRU. So LRU stands for least recently used. So what does that mean? So least recently used means the number which is not yet been replaced for a long time, that number will get replaced. So here we have a page sequence which has been given and frame size as 3, which means our memory will have 3 blocks of size. So let's start with our concept in order to understand how LRU actually works. So the first number, or simply the first page sequence, is 0. That means we'll check whether 0 is available. No. So we have a page fault over here. So we'll denote the page fault with the mark as tick. So we have 0 and the rest as empty pages. Next is 1. Again we will have a page fault because 1 is not present in our memory. So then we will have 0, 1 and then one empty frame size. Next we have 4. Again a page fault. So we have 0, 1 and 4. Next number we have 2. Again page fault because 2 is not present in our memory. So we have a page fault. And now the question arises, which particular page to be replaced or which number to be replaced. So as we are doing LRU, which says that least recently used. So 4 is been used, recently used, 1 is still recently used. So least recently used, which means the number which is not been used for a long time or which is not been replaced for a longer period of time, is the number 0. So we will simply replace 0 with the number 2. So we have 2, 1 and 4. Simply replace the number 0 with the page sequence of 2 and rest all the things keep it same. Next is 0. So we don't have 0 over here. So again a page fault, and we'll check the least recently used number. So 2 is recently used, 4 is also recently used. So the number 1 is the number which is not been used for a longer period of time. So we will replace 1 by the next page sequence, which is 0. So we have 2, replace 1 to 0 and over here 4. Right? Next is number 2. So we have already 2 present. So we have a page hit over here. Page hit means when the number is already present in our memory block size. So there we have a page hit because the number is present. So no need to change anything. Keep the same thing. 2, 0 and here 4. Next is number 6. So we will have a page fault because 6 is not present and the number to be replaced. So 2 is been recently used, 0 is also been recently used. The number 4. So the number 4 is not been used for a long time. So we have 2, 0, 6. Okay. Next is 5. So again a page fault. So 6 is been used, 2 is been used, so 0 is the number which is not been used for a longer time. So replace 0 because 6 is been used, 2 is also been used, so 0 is not been used for a long time. So 2, 5, 6. Okay. Next is 1. So again a page fault because 1 is not present over here. So 5 has been used, 6 is also been used, number 2 is not used for a longer time. So we have 1, 5, 6. Next we have 2. So again a page fault because 2 is not present over here. So 1 is been used, 5 is been used, number 6 is not used for a long time. So 1, 5 and replace 6 with 2. Next is number 3. Again a page fault. So 2 is been used, 1 is been used, 5 is not used for a longer time. So 1, 3, 2. Now 2 again. So we have a page hit because 2 is present. So we'll keep it the same. Again 1. So 1 is present. So keep it as it is. 1, 3, 2. So this we are having page hit over here. Again 2. We have a page hit because 2 is present. So no change. 1, 3, 2. Now we have 6 over here. So page fault because 6 is not present. Now which one to replace? So 2 is being used. 1 is also being used, recently used. So 2 is again used. 2 is used for a very long time. Okay. And 3. So number 3 is not being used. So if you check, so 3 we have 1, 3, 2, right? So 2 is being used. Next 1, 1 is also been used, 2, but we can't take 2 because 2 is again used. So 2 will be the very recently used number. So after 2, which one is used? Number 1. Okay, so we can't take even number 1, but number 3, because 3 is not been touched for a long time. 2 is being modified, even 1 is being used. So 3 is the number which is not been used for a longer time. So simply replace 3. So we have 1, 6, 2. Now number 2. So number 2 is present. So we have a page hit over here. So same 1, 6, 2. Keep it as it is. 1 again page hit 1, 6, 2. So 3. So page 4. So 1 is been used. Which to be replaced? 1 is been recently used. 2 is also been recently used. Number 6 is not used for a long time. So replace 6. So 1 replace 6 with the next number, which is 3, and here 2. Next we have 6. So again a page fault. So 6 is not here. So 3 is been recently used. 1 is also been recently used. Number 2 is not used for a longer time. So number 2 will replace 1, 3, 6. And the last is 2. So again a page fault because 2 is not present. So recently used numbers are 6. Find the first recently used numbers. So 6 is recently used. 3 is also recently used. So 1 is not used for a long time. So we'll replace 1 by 2, 3, and so we'll replace 1 by 2 and we get 2, 3, 6. So let's count the number of page faults. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So total number of page faults we get is 40. So total number of page fault we have here is 40. So that's how LRU works. You just have to check the least recently used number. Okay. In this case, as so here it was a bit complicated because 2, 1, 2, 3. So 3 is not been replaced for 1, 2, 3. 3 times the number 3 is the same. It is not been replaced. 2 and 1 was replaced many a times. Mostly 2 was replaced 2 times and 1 was replaced 1 time. But 3 was still there for a very long period of time. So that is the reason we replaced the number 3 over here with 6. So that's how LRU works. Okay, and that's it from this video. Thank you so much for watching and don't forget to subscribe.